Hi everyone, we're going to go over multi-step equations again today. So when we have a multi-step equation, we're going to want to follow these steps. Sometimes it can get a little overwhelming in the beginning, figuring out where to start with all the parentheses, all the variables, all the constants. So I'm giving you 6 steps to work through if you don't know where to start. So the first thing you're always going to want to do is distribute. And anytime you see parentheses with a number in front or a symbol in front, you're going to want to distribute. Then you're going to want to combine your like terms. By like terms, I mean all the variables and all the constants. And those are the variables and the constants on the same side of the equation. Once everything is cleaned up on each side of the equal sign, you're going to want to move all variables to one side of the equation and all constants to the other. Variables are letters that represent numbers, and constants, if you remember, are numbers that stand by themselves. So the important thing to remember when you're moving all variables to one side and constants to the others, inverse operations cancel out. And what I mean by that is inverse means opposite. So the opposite of subtraction is addition. So if you have something like x minus 4 equals 5, you have minus 4. To cancel out the minus 4 and move it to the other side, you're going to add 4 to both sides. What you do to one side, you do to the other. So the important things to remember are addition and subtraction are opposites or inverses, and multiplication and division are inverses. Then you want to divide both sides by the coefficient, whatever is in front of the variable, in front of the x. Last but not least, you want to check. So to check your work, what you want to do is take your answer, plug it in for x, and use PEMDAS on both sides to solve. So let's go through exercise 1 together. First thing you want to do, as our steps say, is to distribute. Distribute on both sides. So negative 3 times x is negative 3x. Negative 3 times positive 3 is negative 9. Plus x, because we do nothing with that, equals. There's nothing to distribute on the right, so we're going to leave it be. Next thing we want to do is to combine our like terms. So in this case here, on the left side, our like terms are negative 3x and positive x. You always want to count that symbol in front of it as positive or negative. So we have negative 3x plus x is negative 2x. We can count the plus negative 9 as a minus 9. There's nothing to combine on the right side, so we're going to leave it be. Our next step is to move all the variables to one side and all the constants to the other. So let's move the 2x to the other side of the equation. So the opposite of negative 2x, positive, or you're adding 2x. What you do to one side, you do to the other. And remember, you can only combine terms that both have x's or both do not have x's. So negative 9 equals negative 3. Negative x plus 2x is positive x. Now move all our constants to the other side. To know which constant to move, you want to get x by itself. So whatever is on the same side of the equal sign as x is what needs to be moved. So in this case, that's a negative 3. So we add 3 to both sides. So we're left with x equals negative 9 plus 3 is negative 6. Don't forget your integer rules. Now to check it, what we want to do is take that negative 6 and plug it in anywhere we see in x. So negative 3 instead of x. I'm looking at the original equation now. I'm rewriting everything else, but for the x's, I'm plugging in negative 6. Alright, then we use PEMDAS on both sides. Negative 6 plus 3 is negative 3. Plus negative 6, rewrite the rest of that equation. And negative 3 times negative 3 is 9 plus negative 6, which is 3. 3 minus negative 6, we can keep change, so negative 3 plus 6, which is 3. 3 equals 3, it checks out. Alrighty, our next equation, we're going to do the same exact thing. We're going to start off with distribution. 2x minus 8 equals x plus 4. We want to move all our variables to one side. This is positive x. If there's no symbol in the front, it's positive. To undo that, you want to minus x from both sides, subtract it. So we get x minus 8 equals 4. To get x by itself, we need to move that 8 to the other side of the equal sign. So we get x equals 12. Now to check it, we're going to plug into that original equation. So we have 2, instead of x, we plug in 12 minus 4 equals, instead of x, we plug in 12 plus 4. 2 times 8 equals 16, and that's true. 16 equals 16, it checks out. Alright, next we're going to start by distributing once again. So we're going to leave the left side the same because we do nothing to it. 3x minus 4. Next thing we want to do is move our variables to one side. So we're going to subtract 3x from this side, subtract it from this side, and oh no, cancels out on both sides, and we're left with, I forgot to subtract 3, and we're left with negative 4 equals negative 3. Since there's no x left, we either have no solutions or infinite solutions. If the equation or if the statement is true, then it's infinite solutions, meaning anything you plug in for x will make the statement true. If the numbers are different, then it will be no solution, which means that no value for x that you plug in will make that statement true. So, since negative 4 is not equal to negative 3, there is no solution to this problem. Alright, next one. Again, we're going to start off by distributing. Don't forget your integer rules. Negative times a negative is a positive. We're going to distribute on both sides. Now we're going to combine our like terms. There's nothing to combine on the left, so I'm just going to bring it down. On the right, though, we can combine our x's. Don't forget to count that symbol in the front. Negative 3x plus x is negative 2x. And we can combine our constants. Positive 3 and negative 1 gives us positive 2. Now we want to get our constants to one, or our variables to one side, so we add 2x to both sides. And again, they cancel out, so we're left with no x's. We're left with 2 equals 2. Remember, if the statement is true, it's infinite solutions, meaning anything we plug in for x is going to make that statement true. If the statement is false, like it was in number 3, then that means there's no solution, meaning that nothing you plug in for x is going to make that statement true. So since both sides are equal, we say that we have infinite solutions. There's also a topic called one solution, or there's also a situation called one solution, and all that is a fancy way to say what we did for examples 1 and 2, meaning there was an answer. Alright, and that's all you need to know for multi-step equations.